Good evening. Well, I went camping, and I don't know if I just breathed too much campfire smoke or caught something off someone else, but I'll be using a lot of these this stream. On my nose, get your mind out of the gutter. And apologies if I forget to mute. But the show must go on. This is a robot show. Don't know where I put my to-do list. It's got to be around here somewhere. Do-do-do-do-do. Do-do-do-do-do. One of these, perhaps? Let's get that open there. There we go. That's too big. Let's smallen it. And I should just also move myself along here. Just got to kind of like, get it to move. Man, that chair is squeaky. I need a fresh one. Just donate a bunch of money and I'll get a fresh chair. I think that's how this is supposed to work. Something along those lines. Yeah. So, I've been working on this interesting. This is sort of the core mechanic for this robot game. The robots get programmed into factories that you control, and once they leave the factory, they just follow their programming. And so this is their programming is represented in a graph. It has been a got to roll up the sleeves before you start doing some wizardry, of course. It was just a linear track of actions that they would keep looping through, but now it's becoming more of a graph node with decision points in it, none of which work right now, but they will. And that's what I'm working on at the moment. So I think last stream got the data model underway. And so I think I've got part of that, and possibly to some extent I've got that data model being built up as the nodes are linked together. But I don't quite remember where I got to with that exactly. So let's go and take a look. So here we are. I do need to sort of rearrange how all of this works, because I think this is not necessarily going to be the most easy to follow. I've been using the magnifier, but I think I need to just set up a better scene that'll better show what's going on. But let's stick with magnifier for the moment so that it doesn't take too long to get up and running. Yes, that can go there. And yeah, let's go with that. So what we've got here are some just a random assortment of nodes for a routine graph. The graph starts here at a start node, so I'll pop that over on the left there. And then you can pretty much plug it into anything, but let's say that we start out with an action of some kind happening, and then maybe we go to a label which does nothing. It'll just jump straight to the next part of the routine, but the point of a label is that we can then go to that label with a go-to. So we could put this over here, for example, and then we might have a signal here which might be, is an enemy detected? And if it is, then we'll do some action that's appropriate for that. And if it's not, we'll maybe do some other action. Maybe we'll walk forward. These all just say action at the moment because I've just kind of reprogrammed it a little. And I haven't got it putting the action name yet. Well, yeah, so if an enemy is present, then fire. Otherwise, take a step forward. And that would be correlating to the enemy sensor in the robot's blueprint. And then in either case, we can jump back to that label and then loop through the same check over and over, just as an example of a simple routine. And here's a different possibility, like maybe just move some of these things around. So maybe if there is an enemy, we want to check, are we above 50 hit points? Oh, there's 50. Okay, so if we're above 50, then maybe we fire. And if we're below 50, maybe we put up the shield. Oh, and if we're equal to 50, also shield. And then loop around the same check. So that's sort of an example of a routine graph that could be put together. But let's make that actually do something, because right now this is just UI. It's not actually doing anything to these robots back here. They're all just basically following these really simple routines. Hang on, maybe I'll pick this one here. Got that one selected, so it's just going through these actions here. Which at the moment is just, oh, it got exploded, so we have to select a new one, but that comes from the factory. But yeah, basically, we'll need to add some sensors to put on there, and then if they've got a laser, they could do a lasering. If they've got a shield, they could do shielding. If you put this on here, they won't be able to turn left or right because that is the budget legs. Right, time for some more tea. Time to spill some tea on myself, not in the gossip sense or whatever it is. Yeah. There we go. Right. There we go. Tea successfully sipped. And now, routines. So the routine graph manager is just kind of creating some things there at the moment. So what we've got here, I'm just having a quick look at where this is up to. So, good. So this is node routine is part of what I was building last time. And so I've actually, it was just creating some of these things, this sort of one-shot script here. Now it looks like I've actually gone and created a routine, and when you create that, it'll have a node 0, which is the start node. And each node in there will have a unique ID that it is assigned. So we've got our start node there. Now these positions, that's something that I've just got configured in that manager. Where have I put that manager? Here's my routine graph manager editor. What is an integer? An integer. Yeah, so I've got these set of positions here, and that's just where it will create various nodes, and this is also holding all the prefabs to create those nodes. And in those prefabs, well, they're basically what you see here. So they've got all that there. And then this is just a little loop I've got where it's essentially just going through these positions. Which is positions to create these things. And then position 0, 1, 2, 3, or 4, it's going to pick a different type of node, and the default is the action node, so it'll just create anything past 4, let's just create more action nodes, and then it's just instantiating them. So these aren't actually part of that routine at this point. At that point, I mean, so we instantiate it, and then add it to new routine. So this looks like where I'm up to. We've got a unique ID. Switching on what iteration we're through. So that's actually putting that start node into that position, even though it's created another one. Oh no, it's setting the position. Okay, yeah. So the routine graph will store not only the connections, like the nodes and their connections, but also their positions, because that's part of what the player has done. They've arranged it. Yeah, so we know this unique ID must equal 0 if we're dealing with the first iteration, because that's the start node. Otherwise, it's going to be whatever unique ID gets assigned when we add something. And so it looks like we're actually instantiating based on these prefabs, but I've also got the same loop here, essentially. Oh, except I haven't got anything for those actions. That's probably why those actions weren't working. And so I think I can just do default and set up the same thing. And in this case, I just basically skipped it because it's going to be action node prefab already there. So that means anything past 4 is going to be action node. I'm going to grab everything here. Yep, everything there. And just duplicate it for the moment. Okay, so it's going to be type action. Set the position, and it's not going to have a signal type. So this is for any decision nodes. Where they're going to get their signal from. So is it going to be coming from the enemy sensor, for example? Is it going to be coming from the hit points of the robot? If it's a threshold that takes in a number and lets you set where that number should divert traffic. So yeah, we don't need a signal type in there. And let's take a look at that routine node here. So we've got a few different things in routine node. So we've got the unique ID, and that's used by other nodes to say which node they're connecting to. We've got its position, which I don't know why we've got the public keyword there. We put it there. And then here this will be the unique ID of the other nodes that they're connecting to. Maximum number of connections at the moment is the threshold node with 3, so I'm just doing it like that. Could do an array, but why complicate it? And then, yeah, so here we go. Only for action nodes, we got a robot action action. And you'll see there's that threshold value for the threshold node. And label ID is for, oh, yeah. And if I label and go to nodes, there we go. All right, so I'll just jump back over to here. Unity's just busy building that, which feels bad after using Godot a little bit. Kind of just feel like going and exploring Godot for a while, but I also think I should finish what I've started here, get this to at least a decently working prototype since I'm so close with the routine editor. And I need to go get the family tree game sort of polished off, fill out the content, and get the menus looking not horrible, and so on. All right, so now interesting. So we've got awkward, shoelaser, turn left and right. I might actually get some different values in there, depending on what number we're at. So we know that we're at least above 4. So I might just say -4. Casting, that's not going to work very nicely. What's that all about? I need to charge this device. Oh, it's saying I'm doing a stream. Well, I already knew that. You don't have to tell me. All right. You know, I think I'm just going to do this the low-tech way. So 5, 6, 7. They can have whatever we got. Shoot laser. We got yeah. Let's go turn left. Turn right. Have a shield. Block. Yep, block there. And then we'll just make the default walk forward after that. So we'll have some walk forward one actions perhaps. Okay, there we go. So now we should be creating all the right things. Okay, so we're actually looking up the node at the end here. And we've got the unique ID from what we created there. So that's what we're using to get it. Now, routine node UI. So that's out of the created game object. We're getting that. We're actually setting this routine node into there. And they're looping. So now we've got that node set in here. And that's about it. So what happens when we set that in there? So we have a routine node that's been set. Nothing happens. This label and label text, that's just something for me to set so that I can set these things. And that's going to happen on start. But yeah, so we're actually updating the routine node. But yeah, we're not actually setting it in the current routine. So let me think a second. So here we set that. So we created the UI there, so I think we need to have a setter for routine node, really. Just here, so we just make that private. Give it a setter. And then when it's been set, we basically want to update everything. I'll just put that sort of to do in there. And I guess probably just want to like update display. Something like that. Generate a method there. Now, routine node UI, is this one of those? Yes, it is. So basically now, given the display, we can update it with that value, and it should be the right type of node for that. So I guess we'll just make this virtual or abstract. Hang on, what's the difference between? Yeah, we'll make it abstract. So virtual doesn't have an implementation. Is that right? Yeah, what's the inverse of override? What is it? C#. Override modifier. The abstract or virtual implementation of an inherited method. You cannot override a non-virtual or static method. The overridden base method must be virtual, abstract, or override. Okay, cool. So virtual. I should remember this stuff, but I do my game development a bit late in the day, so not that much brain left. Okay, so I think I want virtual here. Yeah. We don't want public to, we just want like protected. Alrighty. So what do we want this to do? Well, at the moment, it really just needs to set that label text. Oh, and what do we actually want that text to say? It's going to vary, isn't it? Depending on whether we've got an action or something else. So either going to be the label ID or something depending on the node type. It's going to depend a lot on the node type, so all right, let's start at the start. Yeah, sure. Let's do label. Label ID. Break. Yeah, I like actually putting that break up on the same line like that. And actually that's going to be the same for goto, because they use label ID. All right, so we've got label, we haven't got action yet. What is that action? It's a robot actions. Sure. At some point I'll make that make more sense. I'll just string it for now. Okay, so we haven't done the decisions. We'll just string that enum as well. That's another enum called signal type. And that's going to be the same for threshold decision as well. And I think that's all our node types for now. We got start, action, both decision types, and label and goto. And by default, it'll just break, because we can't set that to anything. And he's also not actually doing anything. Is that going to shadow this text up here? That's called label. Just set that text to unknown. So there we go, now we can set that text. I could pull this switch out into a method that returns the text for a node type. Okay, so that should be setting an appropriate label at least now. Let's make this protected. Maybe. Both of these, I guess. I guess that's the public one. This one can be protected in case we, for some reason, want it to be able to be fiddled with. So this could implement its own update display. Actually, it does have its. As it's got its threshold value that's getting turned up and down. Oh, cool. So yeah, that does give us a natural thing we can do here to update display. We'll just see if that's going to suggest. Nope. Yes, override update display. So we can call base to update that label. And it looks like we've already pretty much got some things to update the display here. Kind of threshold value and so on. Oh yeah, so so we should have a threshold value. So that's going to be relevant. What else do we have? No, I think that's the main thing. The signal type determines the label, but we've already been handling that. So yeah, so this update, maybe refresh display would be a better name for this. So when this is called, that basically means there's a new node. So let's make it all work based on that. I don't know where we get the min and max value from. Like right now, they're just added in there, but that might be something that each type needs to have hard coded or something. I'm not sure. But for now, we can set that threshold value. And we've got display values that'll update the text for that. Init value display, so that sets our min, max, and value. Okay, so I guess this really needs to just say set threshold value is equal to routine threshold value, and I think we just do init value display because that'll set that slider's threshold value and set that text. It'll also reset the min and max, but we don't care about that right now. But that might need to change. There we go. We don't need any of this trouble when I can afford a robot nose. But I assume they're expensive because they don't sell them in the shops that I tend to go to. Okay, I think that's looking decent. I think if I run this now, if I select Unity, is it going to recompile everything? Compile errors, what have we got here? Yeah. Okay, routine. Oh, yes, of course. So change that to a property and made the field private. So there we go. Does that fix it for you, Unity? You're happy now? Yeah, okay. I mean, I guess it's really the C# compiler that we're satisfying here, but Unity's not happy if C# isn't happy. Okay. So interesting. So now we've got start. Yes. These still say action. To do update routine node UI for the set routine node. Got signal, action, and so on. Okay, so this one actually says hit points, so that's done something right. I suspect the others don't actually have any routine node UI implementation on them. I've got these imports here that I'm not using. So I'll go to my prefabs for those nodes and give them the appropriate thing. Yeah, okay, so that's the script I want. These are the node prefabs, so let's take a look at that one. Action node. We do have routine node UI. We've got this action label and label text referring to that label. Decision node also has that on there and says signal, so that is actually updating to say signal. Got to go to. The thing is, we might be hitting the start after we've hit the update. So I might need to just remove that start. Yeah, I've got it updating to say label ID. Cool. Yeah. Okay. So all of these seem to be just hitting this label here. So if I just stop using that, because that's just something that I had set for fun. All right, now here, that's where we actually set that, and it should trigger those changes to run. Oh, so we've got the that threshold node. Action, threshold decision. Position, signal type, yeah. Threshold value is what we want. And let's start it at 25. A quarter health. That's probably a reasonable place to change something. Oh yes, I've got them using the label A. Because that would be the default. Right. So now let's see if we get something. Oh yeah, that's better. So now we've got to turn left. We've got to turn right here. That's a shoot laser, a block. Not making great use of that available space for that text. There we go, hit points set to 25. And we've got A, which doesn't really distinguish from these default A things. That one says enemy. That's interesting, because that's the default. This says start with like lowercase. Oh, here we go. That's enemy in all caps, and this is not. And so that's going to correlate with that enum value for the enemy sensor. So, yep, that is working. Setting the labels, setting that threshold. And have I got that threshold node UI set so that when I change this, we get a new threshold value there. And then that'll display that new value as text. So the other thing that should happen in here, oh, hang on, infinite loop alert. I'm just going to say when this is set, it should set the routine node. I'll just maybe put that even right here. Threshold value in that routine node. Now, is that going to lead to anything happening here? No, that's just a struct, isn't it? I need to check if that actually will work to update that. Because it should be changing the underlying representation. And setting routine node should do that. But yeah, if we call refresh display there, then that's going to run refresh display. And so on. But yeah, actually we're not really setting that value on value change check, so that's fine. Otherwise, we're just setting the internal representation. So I think that's okay. But I think also we need to say do that to call the setter so that it makes sure that it runs the setter. I'm not sure. Just do that just in case. But we're not doing it anywhere yet. So I'm going to get that to do. So I better start making this routine graph manager work properly. So it should be a singleton and present its changes to that's showing the update that I need. That seems like it would update every time you change that value, which is what I want. Decision node, negative connector, connection node, clone, and done clone connection. Where am I generating that from? Just here, this is my log for input drop target. Okay, so that was obviously while I was getting that working. Okay, so let's get this routine graph manager actually being a manager instead of just running some arbitrary stuff on start. So I think first things first, let's make it a singleton. This is a singleton, isn't it? But we've got an instance, a static one. Yeah, I'm not going to do it that way. That's that's not my code there. I think game manager is going to have what we want here. Just grab my game manager script. And I'll just grab this slot here that I used to make it a singleton and just give this the same treatment right there. Now this of course can have an error because it's not a game manager, it is one of these. Routine graph manager, and I'll make that say routine graph manager as well, so it makes sense. And this essentially just logs an error and destroys it if there already was an instance. So it basically just requires you to put one in the scene. All right, cool. So now I can get access to instance. That's something I'm not now doing, but I'll just leave it there in case I need it. Get rid of it when I'm cleaning up. All right, so here we are. So this is now where we're going to have a selected routine. I'll make that private, I think. Now on start, we're creating a node routine. Yeah. Current routine, so that's going to be based on the selection at some point, but for now we'll just make it be hard-coded. Well, not exactly hard-coded. It's going to be this one here. So create current routine here. We looped through some things. I don't think we return at any point in there, do we? No, we don't. So we just loop through these. And then these are just other sort of example code that I can use at some point. Yeah, no, that's not what I need. Routine, probably can change that to selected routine. Equals new routine. So now we'll have a selected routine. There we go. So selected routine equals that, and now we need a way for other things to interact with those. So that, I guess, will be public method. And what are we going to update? So we've got our routine nodes, which should have a unique ID. So I guess the simplest would be just something along the lines of update node. I have the node that is to be updated. And we'll just pass along that update node to there. That looks good. Certainly looks good enough. Routine graph manager dot instance dot update node routine node. Nice. And yes, I haven't got any way to create new nodes in the UI yet, but when I do, it'll be happening through that manager. Okay, let's see what this one has got. Oh yeah, so that's just making sure that the setter, this one, so it's on drag complete. We update the position, so then we update it. Also, just if we set it into here, then that'll be a signal to grab that. Is that all right? It's going to set it back into there when T node is set. But that might actually be bad during this bit here when we've got this. Before we've done that, so we've called add node for each of these. There. So calling that will actually call an update when this routine is not actually set in here yet. So that is not desired behavior. I think instead, We'll just call this propagate changes, which is just going to do basically that with this. Now, am I making this more complicated than I need to? Oh, hello! Indra Madinata. Welcome. Oh, geez, that was half an hour ago almost. Oh, 20 minutes. Apologies for that. That means I have forgotten to open Chatty, which would have made a noise when you sent your message. So I'll do that now. And hopefully you're still there, or if not, hopefully you got something useful. That's not what I want to move. Actually, I don't need to see that, do I? I can just sit behind there. Cool. Alrighty. So now I'll hear no messages. So now I just need to call propagate changes anytime I do something that actually makes a change. Oh. Yeah, propagate changes. Yes, what this is. Do need to have a little bit of a look at C# structs. But yeah, maybe making it more complicated than I need to by using structs where a class would be able to pass by reference. Not sure. So yeah, we set that threshold value. So I'll actually call propagate changes instead. That's like the proper change, and that's the UI update. I can even put that here. Rather, that bit of it. Now, how can I tell if this is actually working? So I can get the debugger going. Oh yes, I'll need to move this because that's not going to work there. At the moment I call something in there, it's going to do something. There we go, so we can say that's the selected routine right now before we start messing with things. So that's fine. And then I guess every time this gets updated, we could do something. Set a breakpoint. Touch the debugger. Let's see what we can get. Right. Oh yes, of course, because it's happening all in start. So we've got update node been called with what? Oh, nothing, because we're not actually paused, are we? Are we paused in debugger? If we were, we would have a play button somewhere. You are just compiling for debugging. All right. Oh, now here we go. Wait, is it running or not? Okay, so we've got a routine node. So the good routine is null. How did we get here? We've got a call to propagate changes because we set the threshold. Is that going to give us an error? Null reference exception. Yep, not surprising. But that might happen a little. So most of these nodes haven't been updated, but then I think anytime I move something, it should update. Oh, yeah, I guess since I dropped that, so that was the start node. So yes, this says start. Action is walk forward, which is, that's just 0. No action. Yeah, node type is start. Don't have any of these outputs or anything. Interestingly, no output means like value of 0 is going to be the ID of the start node, which everything that's not connected to something will go to the start node. So that's useful. We've got the position here. Signal type, again, it's not a signal node, so it's just defaulting to 0, which if it was a signal type would be 0, would be the hit points signal, and so on. And so we've got a routine. The next ID that will be issued is 9. And so we've got all these nodes in here. So we've got the start node, unique ID 0. And we have another start node, also with unique ID 0. That's not so good. And node type, we've got a simple decision with enemy signal, unique ID 1. And oh yeah, because I'm actually creating another one when I shouldn't be. Okay, so we've got a node type label ID A. We've got a goto label ID A. Got a threshold decision with signal type hit points, threshold value 25. Okay, its ID is 4. We've got another threshold decision. Hit points 25 unique ID 4. Wait a minute. 4. That's doubled up. And then we've got 7. Index 7 has got a action, a shoot laser action, unique ID 5, and over here, unique ID 6, turn left action, ID 7, turn right action, ID 8 has a block action. But yeah, we do have multiple start nodes in there, which doesn't make sense. Doesn't make sense to have, and it does make sense that we've got that, because this creating a routine creates a start node, which is why that's the start node there. And then we're basically using those positions. It's going to instantiate the start node. But then, oh yeah, it's not adding another one, it's just using the start node position. And it's instantiating this to represent that. Whereas the others are actually creating. So maybe update node has a problem. Give it a node. Grabs the unique ID. Finds the index where that is the case, and we'll get this warning logged, which it doesn't look like we have. Try starting that up again, perhaps. Oh, we're paused in debugger, aren't we? So I'll just clear this and do that. Routine graph manager 221. Calling update node. If we don't have a selected routine, let's say for select routine is no. There we go, click on update select routine. There isn't one. Verbose, but that's okay for the moment. So now it won't hit that null reference. Now, is the presence of these going to be causing a problem? Not sure. Is that going to be pausing somewhere? So I've got the drag complete message. Oh, right, that's where my breakpoint was, and I've changed that code. Oh, here we go. So selected routine is not equal to null. That looks like a lot more than I remember adding. So we're going to start with ID 0, but the fact that next ID is 9. Now we've got 32 nodes, that definitely tells me something wrong is going on. So we've got to start with ID 0 again. These IDs are supposed to be unique. There's another one. Another one. So yeah, definitely something very wrong with that. Got a walk forward decision node. Sorry, that's ID 3, 4, 4, 4. Yeah, I have a feeling that update node is not updating node. I have a feeling it is. Oh, yeah, there's your problem. Let's see, insert. I think this might be more like this. Okay, I have a feeling that we'll end up with something a lot more appropriate here. A routine with not so many things. Next ID 5, count equals 5. That seems good. We've got a start node. And then we go to unique ID 1, 2, 3, 4. Now these don't have to add up to, they don't have to correlate to the index. And if nodes are removed and added, then that's where this next ID will start to get out of sync. But what we definitely don't want is two nodes to have the same unique ID. Alright, so we've basically got all those nodes there. Now I'll move the start node. Now we're paused here. We're adding, or we're updating start node. Count equals 9. We got the start node there. And we have a simple decision node there. And I'll just move that again. And we should still see the same thing. Start node there. Simple decision there. Cool. Now, all of these nodes aren't actually... Oh, I guess they're all part of the routine, but they're just not doing anything. That's fine. I guess it's just whatever's on the board that is a part of it. Now, I don't think I'm doing anything with their connections. We're paused in debugger, so that's not going to work. So, like when I do that, I don't think I'm doing anything with that. So that's the next thing. We'll get those connections updating. I might get rid of that breakpoint for the moment. I probably should add something here. Oh yeah, UI behavior. So basically, update the routine when nodes are moved. I'll just check that one off because I've just done that. There we go, that feels good. What's next? The thing I was about to do. Update routine, and connections added, changed, or removed. not nodes, nodes. Allow adding nodes to the routine. Right now, there's just no way to do that, except in code. All right, so we'll do this one. Update the routine when connections are added, removed, etc. So I think we're looking at something that I have moved. That's something that I've closed here. Input drop target, I believe, is the one. So it will detect a drop. I'll grab the dropped object, see if it's got an output connector. That's what we're expecting. Okay, so now it's changing some stuff. That's when you try and plug it into itself. Just doesn't work. Okay, then when you're logging, what we're doing. Setting it to plugged in true. All right. So that stuff's not unusual. So at this point, it's like if we look at one of these guys, let's have a look at this star node. It's got this output connector on it, just there. And so that's going to be dragged over and dropped onto here. So it's the script for this that we're looking at. Does this output connector have any link other than its nesting to its parent? So I think that output connector probably just needs to give like a plugged in signal of some sort. Yeah, so I guess at this point, okay, we got the output and input, output and input. Right, hang on, we've got the output rect transform. So this is finding the connections. So basically we've got that connection from start to here. So it's finding that connection, getting the first one, and getting the output node. So basically now it's actually got that start node. Oh yeah, so that's for checking it. And we don't do anything, we just set plugged in on the icon so it won't go elsewhere. And parent it to the plug so it stays plugged into the plug, and set its position to be the position of the plug. So yeah, I think we got some more stuff to do here. Basically need to set the connection in actual routine. So that's going to involve, since we actually have the output node, so output node is the actual node. Are we checking if that is equal to input transform? Transform.parent. So that's actually got that. But we want the node, so I think what we need is a routine node UI for each of those. So we've got that, and we've got that. Yeah, that was what I wanted. And that's not what I want. That. Oops, wrong. So we'll get that input node UI. I guess that should be both of the node UIs. And it's really just that T's on that. We need the unique ID for each. Grab the routine node, its unique ID. I don't think I need both of those, but put node UI dot routine node dot oh, which input? Output, I mean. Now, what's this warning about? Routine node. It's got a getter and setter. go, output that. So get that node, the routine node, and we set output 1 on it. So let's set correct output. So that's probably set output number in prefab for the connection. But for now we'll just do output 1. So that's setting that. And now we want set that routine node equal to the one that we just cached. So that will be with the updated output 1 to point to that input ID. So that's when it lands on it. We also need to handle that's like added, changed. So I guess if they're changed, oh, actually it might not be a matter of fix me. So when they're removed, that's going to be instead on like drag start. So we've got this output connector here. So when we begin drag, it's not plugged in. Okay, so given this output connector object, what does input drop target do with that? So we get the event data, get the dropped object, we get the output connector on it. Yes, I think I just need to check its parent or the other end of the connection. I guess this is the standard way I have right now. Do I want to do that? Just deciding whether to do that or just get the parent. I guess this is a bit more reliable. Shows exactly what it is attached to. that comply with that. So now we find the actual node. I'm not going to pretend this is the most efficient code. So I'll grab that T-Node UI here. So now we've got the routine node object. And we just want to make sure output one equals what do I actually want to set that to? Not connected. -1. Does -1 mean not connected? I guess we also just could say 0. So it connects to start. Not sure if I've done anything with that. Oh, and now we need to get the routine node. That's not at all confusing, eh? Too many things called node and routine node with variations. There we go. Set that back into there to set it up without that connected. And then if you drop it on another one, that'll handle that. So that's handling removing, and it's also handling changing, because when you start drag, it removes, and then when you drop, it may add it. Okay, so I guess we have that breakpoint in place, possibly. This would be a lot more exciting if I had this hooked up to a robot rather than just looking in here. Okay, so I'm just going to drop start onto this enemy node over here. And it looks like I maybe don't have that breakpoint set here anymore. Let's set that breakpoint. And I'll just move this node there. Okay, so what we should have here is a start node here. Has got an output one. Okay, so that is 0. Now, what is the enemy action node? That's a simple decision. Yeah, that's the type. Signal type enemy, yes. Unique ID is 1. Output 1. Well, it shouldn't have its output set to anything, but start node should have its output 1 set to, oh, actually, is that what we've got here? We've got a simple decision node. Oh, that's the one that I was just moving. So, yeah, we should have start hooked up to number 1. Just looking at these unique IDs, making sure that they're as unique as they should be. All right. Did I save everything? Looks like I probably did. All right, so what's that? That's when you plug in the connector on input drop target. Thing on console here. All right, so let's have a look. On input drop target, when the thing is dropped on there, so we're looking for the output node. Yeah, we're finding IDs. And that is, oh, more viewer spam, hey? Well, now we have this for those. Thanks for playing. Better luck next time. All right. So we're setting output 1 to the input ID. Yeah. That should be right. We'll just log that out a little bit there. Wait, we don't need to do that. Maybe just breakpoint here. So that should be, yes, anytime we drop something on there. So if I were to drop this on there. So now we've dropped this and the input ID is 3, so that is the thing receiving input. So 3 should be the go-to. Input ID 3. Do I have an output ID? Unused. So the output, the thing that has the output from it, should be a turn left action. So yes, action turn left. Output 1 on that is currently set to -1, which is the wrong number. I shouldn't have that. So we've got the output routine node. Still the turn left action. Output 1 is -1. And that input ID is 3. So if we now step I'm gonna step over. So now output node UI, output routine node. Yeah, output routine node. We got output 1 equals 3. And so output node UI dot routine node, we're calling that. And yeah, don't care about that. Oh, going into the depths of some code here. Let me just hit continue instead. So now that that has happened, what if I put this on here? There we go. So now we've had that thing's ID is 6. Yeah, just setting that. Output routine node to output 1. So setting output 1, even though that would be the second output. Doesn't matter. Haven't coded that yet. So this output routine node here has output 1 connected to 6. That's got unique ID 1 and it had output 1 as -1. So that looks like it's doing the right thing. And I kind of want to get that breakpoint over at here. Oh, am I not hitting that breakpoint? That's a bit of a problem then. So if this is doing this, but not calling propagate changes, then that's a problem. We need to propagate changes on that. There was a reason that we weren't just just doing that, right? So if I drop target here, there was a reason that it wasn't just doing propagate changes. Here's routine node UI. And I think that's because of how I was initially setting it. So I didn't want to set it back into there. But that basically means I can't set it unless I just make this public. and then go over here, and it's actually fine now. So after we continue after that, we should see it pausing at the update. And I'm just about out of time because I'm just about to fall asleep. There's got to be edge of your seat gripping stuff here. Alright, so let's just let it continue through everything there. And okay, let's just go start to enemy. That should be 0 connecting to 1. So it's inputting to 1. And we'll just do that. We should have now output node UI routine node is equal to at the start, and output 1 is 1. So that's what we expect. And if I continue from here, we immediately hit update node for selected routine. So we've got the selected routine, we've got our nodes, and here's the start node with output 1 pointing to 0. And this should be the one in the ID 1, which is the simple decision. And now if I step over that, now we should have this. Yeah, that's changed to B1. So that is working as expected. And so now that bit of info is available. This is just updating a position. It should be. Same with that. If I unplug it, it should end up with something. Oh, are we not propagating that change? Plug in we are. Unplug. We're still paused here. So unplug should be updating, and it seems to not be updating. So that's the output connector. We'll just do 0. So that's the start node anyway. And here we just need to propagate the changes. I'm sure there's a nicer way to do this. But that should do the trick. Okay. Alright, well, it looks like I'm out of time. I still haven't got a robot following this routine, but the fact that I'm, I think, updating the routine every step of the way means that it shouldn't be too far off that. Let me just continue through the initial setting. And let's just have this block. So that actually is going to be very hard to control because we are calling update node every time. We probably don't need to be just here. So basically, if we already had a connection, then we're not going to worry about it. Or if we didn't have a connection, rather. There. If it wasn't equal to 0, then we set it to 0. So 0 means the start node, and that's actually where things will go. If the routine hits something that's not plugged in, it just will go back to the start automatically. So that's actually completely appropriate. We're just going to make sure that when a routine is being displayed, that I don't try to draw this connector connected to there, because that 0 doesn't mean that. Yeah. That should do the trick, I think. So now I'll be able to see that working without it also showing me every time it's not doing anything. Oh, now I'm over time as well. So I'll just quickly see that working. Okay, we'll go past here. And now when I pick this up, it should be fine because it wasn't connected yet, but I'll plug it into, let's plug it into shoot laser. Okay, so now the input ID that we're going to is 5. And output routine node, this thing here. If I just go like that, we've now got output 1 set to 5. And this is node 8, so that's 8, that's 5. So we can continue from there. And now if I disconnect that, oops, no, if I just continue again, because it's getting the update, disconnect that. Yeah. So now we're getting an update, an updated node that should have that output set to 0. This is ID 8. And the selected routine. Does this one have ID 8? It does have ID 8. Its output is set to 5, so it's going from 5 to 0. Which is what we expect when we're unplugging it. So that's cool. Yeah, so that'll do for now. Next time I'll just make a note. Doesn't have a letter N. Instead, so I need to set the correct output instead of just, instead of always 1. Probably just select output in prefab. So I could do that, or sibling index would probably also have the same info. All right, so thank you for watching. I've been David from Pedal Pixel. I've been working on this robot game. Kind of want to go play around more with Godot, but I also really want to get this thing working because I've been chipping away at it and it's getting closer and closer. So thank you for watching. I will see you next time.